So in these videos showing the process of elimination, we're going to start with the simpler ones first and work our way gradually to more complex systems. Now in both of these systems, in A and B, we're going to be able to eliminate a variable by simply adding the two equations together. Where if you'll notice in this first one in A, if we were to add these two equations together, and we added 5y and negative 5y, the y's cancel. They become eliminated. That's why this is called elimination. Get it? Clever. Anyway, so the y's will be eliminated if we add these two equations together. So that's what we're going to do. We're just going to add these two equations together, and then the y's will be eliminated. So 2x plus 6x, that is 8x. And again, the y's cancel. And when we add 17 and negative 9, we get 8. And now we're down to one equation in one variable. So x is equal to 1. So that, once again, that is the x coordinate of the point of intersection. So make sure you're writing these solutions as a point. Now, to find the y coordinate, you take that one and plug it back in for x into one of these two equations. And honestly, it does not matter which one you use. I'm going to choose to plug it into the top one. So 2 times 1 is 2 plus 5y is equal to 17. And then we just solve this for y. We'll subtract the 2 to solve for y, so then 5y is equal to 15. 17 minus 2 is 15. And then dividing by 5, y is equal to 3. So that is the y coordinate of the point of intersection. Okay. And just to again verify that this is our solution, you can test it into both equations. 2 plus 15 is in fact 17. 6 minus 15 is negative 9. So we know that that is our solution. Now in example B, once again, when we add these two equations together, the y's eliminate. Negative 6y plus 6y cancels out. So when we add these two equations together, 5x plus 3x is 8x is equal to negative 32 plus 48 is positive 16. And then we divide both sides by 8, so x is equal to 2. So that is the x coordinate of our point of intersection. And once again, to find the y coordinate, we substitute 2 in for one of these x's. I'm going to go ahead and substitute it into the bottom equation. So 3 times 2, that is 6, plus 6y is equal to 48. And then we solve this equation now for y. So we subtract 6 from both sides. So 6y is equal to 42. And when we divide both sides by 6, we get y is equal to 7, which is the y coordinate of our point of intersection. And just to verify that this is true, I'm going to substitute 2 and 7 in for x and y respectively in both of these equations. So we have 10 minus 42 is negative 32, so it works in the top one. And 6 plus 42 is 48, so it also works in the second equation. So therefore, it is a solution. Now, starting with C, we're going to talk about what we can do when a variable doesn't eliminate just by adding the equations together, and what we can do then to force a variable to eliminate. So we're going to start ramping up the complexity of these problems a little bit.